Number 10 is a fairly straightforward substitution problem. The best choice of u that we could make is just everything that's underneath the square root. So if we let u equal 1 minus x to the fourth, we need to figure out what to do with the dx. So we're going to take the derivative of u with respect to x, giving us du dx is negative 4x cubed. If you notice now, the x cubed here appears in the original integrand, which is a good sign. It means that's going to cancel out. Solving for du, we get minus 4x cubed dx. Now remember, our goal is to turn an integral that's originally in terms of x into an integral that's in terms of u. So we want to get rid of all the x stuff, replace it with u stuff, and du. So we have a match here in that the 1 minus x to the fourth in the square root is just going to become u. We have a match here between the x cubed dx and the x cubed dx in the integral. We're just a little bit off by a constant. So there are a couple of ways that you can think about this. One nice way is to bring the negative 4 to the other side here, so that you have minus 1/4 du is x cubed dx. So what that means is we're going to take the x cubed dx in the integrand and replace them with negative 1/4 du. We're going to take the 1 minus x to the fourth and replace it with u, and then this negative 3 is going to stay, because we haven't touched that. So let's see what we get. We said our negative 3 is going to stay. We said the x cubed and dx get replaced by negative 1/4 du. We said the stuff inside the square root is u, and then we can put the minus 1/4 here if we want, or we can stick it outside, and we get negative 1/4 du. Okay, so simplifying, moving things around a little bit, we could put the negative 1/4 and the negative 3 out front, giving us 3/4 integral of, now for the square root of u, it's a good habit to write radicals in terms of fractional exponents, so I'm going to rewrite this as u to the 1/2, and we get 3/4 times the indefinite integral of u to the 1/2 du. Now this integral is just a direct power rule application, right? So we have 3/4 out front, leave that alone. For the u to the 1/2, remember we add 1 to the exponent, which makes it 3/2, and then multiply by the reciprocal of that, which is 2/3, and then we add our constant c. Okay, so we can simplify a little bit. The 3's cancel, 2/4 gives us a half, and then remember u is the substitution we made in the beginning. We said that u is going to be 1 minus x to the fourth. So for our final answer, we get 1/2 times 1 minus x to the fourth to the 3/2 plus c. And again, you can check by taking the derivative of this that you get the integrand that we started with.